Hello students, this is a video on the QA topic tests at Bodhee Prep. So the idea of these tests is whenever we go through the basic concepts of a test, you're not sure whether we'll be able to do the questions in the exam. Is our practice enough? So just to give you that evaluation, these are the tests have been designed. You go through the basic concepts, have practiced the topic, take these tests and be sure whether you'll be able to do the questions in the exam or not. With every test, there is a video. So after the test, you refer to the video. This gives you the solutions and a brief analysis of what should have been the attempt in terms of number of questions, time, etc. There are more than 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description below. So make sure you download the app and make the most of these tests. This video is on the topics Polygon, and this is the second test on the topic. This is an easy to moderate sort of a level of difficulty. There are about 5 questions out of 8 if we are able to do in about 17 odd minutes. That should be a pretty good attempt. If we look at the questions, the first question says PQRSTU is a regular hexagon. PQRSTU. Find the ratio of the area of triangle PRT to the area of the hexagon. Now, PRT is an equilateral triangle because PR, PT, and RT, all of them are the shorter diagonals of the hexagon. If this length is it, this length will be √3, the distance between two sides. The area of triangle PRT becomes √3/4 is √3/4 side square, and the area of hexagon PQRSTU will be 6 into √3/4 side square. So the ratio becomes √3/4 into 3a square upon 6 into √3/4 a square. √3/4 cancel, a square cancel, 3/6 is 1/2. Option A becomes the answer. Easy question, not more than a minute and a half to solve. In a regular polygon, the number of diagonals is k times the number of sides. If the interior angle of the polygon is theta, what is the value of k? So from here, we can find out the relationship between k and the number of sides. Let the number of sides or the number of vertices be n. So in case of diagonals, we can say number of diagonals is nc2 minus n, or n into n minus 3 by 2. Number of diagonals is k times the number of sides. So from here we can say n and n cancel. So n minus 3 upon 2 is equal to k. So n minus 3 is equal to 2k, or n is equal to 2k plus 3. The first relationship. Interior angle of the polygon is theta. So theta is equal to 180 minus 360 upon n. But we know that the value of n is 2k plus 3. So from here, we will rearrange to get the value of k. So I take 360 here. 360 upon 2k plus 3 is equal to 180 minus theta. Since the options are in pi, let us replace 180 by pi. So 360 becomes 2 pi upon 2k plus 3 is equal to pi minus theta, because 180 is equal to pi. I take the inverse of this. 2k plus 3 upon 2 pi is equal to 1 upon pi minus theta. Cross multiply. 2k plus 3 is equal to 2 pi upon pi minus theta. Take the 3 on the right hand side. 2k is equal to 2 pi upon pi minus theta minus 3. 2k is equal to 2 pi minus 3 pi plus 3 theta upon pi minus theta. And therefore k is equal to 3 theta minus 2 pi minus pi upon 2 into pi minus theta. Option A becomes my answer. Rearrangement is required. If this is not comfortable, what we can always do is take the value of n as 4, find the value of k, put in the options, check for theta. Then again take the value of n as 6, find the value of corresponding k, put the value for theta in the options and check. At most, at 2 values, we'll be able to find the answer. This or that, I think moderate level of difficulty. Because of the calculation, the attempt time might go up to 2.5 to 3 minutes. If we do the other method as well, suppose if I take n as 4, the number of diagonals here is 2, and therefore k will become half. Number of diagonals is 1 by 2 of number of sides. The theta for this is 90. So if we put the value here, 270 minus 180 upon 2 into 180 minus 90. This will be 90 upon 2 into 90, which is 1 by 2. So option A satisfies. If we put the value here, 2 into 90 minus 180 is 270 minus 180 is 90 upon 90 will not work. K is not 2. If we put the value here, 2 into 180 minus 90 is 90. 270 minus 180 is 90. 2, so not value is not 1 by 2. If we put the value here, pi minus theta. Pi is 180. 180 minus 90 is 90 upon 2 into 270 minus 80 is 90. Here also we are getting k is 1 by 2. So this is also satisfying. Now we take n as 6. The number of diagonals here is 9. Putting in the formula n into n minus 3 by 2. 639. Which means k becomes 3 by 2 times. The number of diagonals is 3 by 2 times the number of sides. If you put the value, and the value of theta here will be 120. Let us put the values here. 180 minus 120 upon 2 into 3 into 120 minus 180. This becomes 60 upon 2 into 360 minus 180, which is 180. Clearly, we are not getting 3 by 2 as k. If you put the values here, 3 into 120 is 360 minus 180 upon 2 into 180 minus 120 is 60. This gives us 180 upon 2 into 60, which gives us the value is 3 by 2, which was the value for k. Hence, option A is the answer. Brute force approach, but it will still give you the answer. The midpoints of four sides of a regular hexagon are joined. Regular hexagon the midpoints are joined of four sides to form a rectangle. Suppose this is the hexagon, we are joining the midpoints 1, 2, 3, 4 to get a rectangle. The hexagon supposes A, B, C, D, E, F. The rectangle supposes P, Q, R, S. What is the ratio of the area of the rectangle to the hexagon? Now, if we join A, B, F, B, in triangle AFB, we can say that QP will be parallel to FB and half of FB. Because QP are the midpoints of the two sides. And therefore midpoint theorem will apply. Now FB will be nothing but the shorter side of the shorter diagonal of the hexagon. Suppose the hexagon has side A. FB will be root 3 by A. Root 3A, and therefore the length of QP, the breadth of the rectangle, will be root 3 by 2A. We have the breadth of the rectangle. Now we look at the length. For symmetry, I'm joining ED as well. Sorry. And to get a triangle, we can join FD as well. Now, since Q and S are the midpoints, we will get QS parallel to EF parallel to AD. If we look at triangle DEF, this is the midpoint. This line is parallel. So suppose this point here is Y. SY will be parallel to EF and SY will be half of EF. Midpoint theorem. So because this is the midpoint and this line is parallel to this line. Since in the larger trapezium we had joined the midpoint, so joining the midpoints will make the three lines parallel. So SY is half of EF. EF is the side of the hexagon, which is this is half of it. And in triangle FAD, again QY is parallel to AD and Q is the midpoint. Therefore, QY will be half of AD as well. AD is the larger diagonal, which will be twice of A. A is the length of the hexagon. So QY becomes A. Therefore, we can say the length of the rectangle QS will be SY plus QY, which is A by 2 plus A, or 3A by 2. We have to find out the area of the rectangle to that of the hexagon. Area of the rectangle will be root 3 by 2A into 3A by 2. Area of the hexagon will be 6 into root 3 by 4 A square. A square cancelled. 2 2s are 4 cancelled. Root 3 cancelled. We get 3 by 6 or 1 by 2. 1 is to 2 becomes my answer, option A. Again, probably a moderate to difficult level of question of about 2.5 minutes to solve. A regular polygon has 27 diagonals. We know that number of diagonals in a polygon is n into n minus 3 by 2. This n is the number of sides. This is given as 27. So n into n minus 3 is 54. Looking at two numbers with difference of 3, 9 into 6 is 54. And therefore, n, hit and trial, n becomes 9. This is the polygon that we are talking about. Find the measure of exterior angle of a polygon. Exterior angle of any polygon is simply 360 by the side. So 360 by n or 40 degree, option A becomes my answer. Easy question, direct formula, less than a minute and a half to solve. What can be the maximum number of acute angles in an octagon in which all the interior angles are less than 180? Octagon. The sum of angles in an octagon will be 8 minus 2 into 180, which is 1080. Or we can write it as each angle of an octagon is 180 minus 360 by 8. There are 8 angles, so the sum of angles will be 8 into this, which will give us 8 cancel. This will be 8 into 180 minus 360 or 2 into 180, which is 6 into 180 or 1080. All the angles are less than 180 degree. Now the sum of 8 angles, 1, 2, 3, 4, 5, 6, 7, 8 is 180, is 1080. If I maximize this angle and take it to 180, I will able to minimize the corresponding angle. And the maximum acute angle will end at 90. Less than 90 will be acute. So what I'm saying is, at the extreme end, I can write a sum where 4 angles are 180 and then 4 angles are 90. 180 plus 90 is 270. Repeated 4 times will be 1080. But we know that all these angles are less than 180. So if we reduce these 4 values, one of the value has to be increased. Suppose this value is increased. Also, we are looking at acute angles. So these 3 angles will also be slightly less than 90. That difference or that reduction will also be added to this. So best case scenario, I can have these 3 angles, which will be 90. Suppose I am reducing each of them by 1. I can have 4 angles of 179, 179, 179, 179. 3 angles of 89, 89, 89. And whatever difference is left, 1, 2, 3, 4, 5, 6, 7. Added to this, this becomes 97, and therefore these 8 angles will add up to 180. At best, I could have these 3 angles, which are acute angles, and 3 therefore becomes my answer. I think easy to moderate level of difficulty question. Just look at the extreme ends and accordingly distribute values. How many distinct regular polygons can be constructed using 24 sticks? Each of length 4.75 centimeters, such that all 24 sticks are used together, no 2 sticks overlap. We could have a 24-sided polygon which uses 1 stick per side. We could use 2 sticks per side. Back to back, in which case there will be a 12-sided polygon. We could use 3 sticks per side. Sticks are not being broken. 6 overlap. This will give us a 24 by 3, 8-sided polygon. We would have 4 sticks per side. This will give us a 6-sided polygon because there are 24 sticks. We could have 6 sticks per side. If we have 5 sticks per side, the number of sticks on each side will not be equal. 6 sticks per side gives us a 4-sided polygon. 1, 2, 3, 4. You could have 8 sticks per side. This will give us a 3-sided polygon, which is a triangle. Any more sticks per side will make the number of sides less than 3, so polygon will not be there. Therefore, 1, 2, 3, 4, 5, 6 type of regular polygons can be constructed. I think moderate level of difficulty, once you realize what is to be done, question could be attempted, though this is not the kind of question that I look at in the exam. In a regular polygon, each interior angle is 12 times that of each exterior angle. If exterior angle is x, interior angle is 12 times, 12x. But we know that sum of interior angle plus exterior angle should be 180 degree. Therefore, x becomes 180 by 13. 13x is 180. Also, we know that exterior angle is nothing but 360 by n, where n is the number of sides. So we can say 360 by n is equal to the value of the exterior angle, which is 180 by 13. And therefore, n comes out to 26. 13 twos are 26. Find the number of sides, n, 26 becomes my answer. Easy question, just put in the formulas and solve. The interior angle of an n-sided regular polygon is an integer. Interior angle of an n-sided polygon is given by 180 minus 360 by n. This is an integer. N is an odd number. How many values are possible for n? So basically, 360 should be divisible by n. In that case, we'll keep getting an integral value. Also, n is odd. So we look at odd divisors of 360. Also, the value of n should be greater than equal to at least 3 for a polygon. Therefore, 360 is 4 into 90, 8 into 45, 2 cube into 45, 3 square into 5. And therefore, number of odd factors would be remove 2 cube. Odd factors will be formed from here. So 2 plus 1, 3 into 1 plus 1, 2. 6. Out of these, one of the factors is 1. N cannot be 1. And therefore, out of the 6 odd factors, 1, 3, 5, 9, 15, 1, 2, 3, 4, 5, 45. 1 will not be counted. N can take these values because n is odd. Hence, option B becomes the answer. I think a moderate level of difficulty, 2 to 2.5 minutes to solve. So if you look at the overall test, moderate difficulty, looking at about 5 questions in 17 minutes. For me, my 5 questions would be 1, 2, 4, 5, and 7. Which are these? This is a question that obviously will be attempted. Putting values, solving will also give us the answer. This can be looked at, may not be something that happens in the exam. Definitely doing this calculation based. Definitely doing this calculation based. Again, maximizing, minimizing will happen. This kind of a questions can prove to be a little bit tricky. So I'm not counting this as a sure shot question. This was a formula based question, definitely counting this one. This again, not very difficult, but not one of the easier 5 questions. So 1, 2, 4, 5, 7 become my 5 questions out of 8.